The purpose of this lecture or set of lectures is, of course, to introduce you to the basic concepts of environmental health. And today we are going to start looking at study designs in environmental health. And this is a very simple introductory lecture. There are a lot of stuff about study design. There are a lot of materials that can be covered in study designs. We shall give you a very basic sense of what study design means in environmental health and what are the different kinds of studies that you can conduct with a few examples. So let's get started on studying study designs. Now, here is a very basic concept about what it means to conduct a study. And think of designing a study as creating a map. And as you can see, a map gives you a general direction once you indicate that you're going to start from some place and you're going to end up at some place. The map, of course, is not exactly the territory, but the map gives you a sense of how does the landscape look like, and what are you going to see, and it sometimes gives you a sense of how you're going to do certain things, how you're going to do the journey. Very similarly, then, a study design is like a map. What are the different components? You start with a question. So just as you start with a general sense of where you want to go, similarly, in case of designing an environmental epidemiological study, you start with a very basic question. And we'll see that there are certain types of questions that we can ask. Then a map lays out the terrain before you. Similarly, in study design, you lay out what kind of strategy you're going to take in order to gain insight about your participants, the measurement process, the analytical process, etc. And finally, using a map, you can see that there is a spatial direction from a beginning to an end. Similarly, using a research design, you can start with a specific question and you can see what endpoint that you want to achieve. So in this sense, a good metaphor of study design is a map, and just think about that when you start doing this thing. So the first task that you have in order to design a study is to ask a good question. And let's take a look at what are the different kinds of research questions that we can frame in the scope of designing a study. Now, there are 5 questions, or rather 5 W's and 1 H. It's a good way of thinking about how we frame research questions. The first W, of course, is who, which is actually the human aspect of the research story that you are going to craft. And who, in other words, is about the age distribution, the gender distribution. Think of epidemiology as a study of the distribution and determinants of diseases. So the first element of that distribution is the human element. And the human element is about the persona of that. So the age, gender, socioeconomic status, occupation. These are all very important W's that you need to consider. The second W is what, which means that what is the exposure? What is the distribution of the exposure in the community? Say, for example, if you are interested to conduct a study on the impact of air pollution on respiratory health, then you would like to know as to the concentration of the air pollutants in various measurement stations spread across the town. That's an important one. If you are interested to find out whether benzene causes leukemia, then where is benzene produced? How does a person come in contact with benzene? What are the exposure variables? That is the what. Where focuses on the spatial aspect, and particularly in environmental epidemiology, the where aspect is very important because there are spatial distribution of the exposure variables that needs to be taken into account when you conduct an epidemiological study, because exposures and pollutants are not evenly distributed in nature. Somewhere you see that there is a higher concentration of air pollution. If, say, for example, we are interested to study air pollution and health, somewhere you will see that the air pollution is high, at other places air pollution are low. Therefore, you need to have a sense of the spatial distribution of this. Also associated with this particular where is a question of when, in other words, the time dimensions. So the pollutants can vary over time. Sometimes the pollutants are higher in concentration. At other times of the year, the pollutant levels are low. So time is an important factor, and it can vary from day to day, to year to month to month. Why and how are two questions that address the other aspect of environmental epidemiological study, that is, determinants of the health distributions and health effects. Therefore, to round it up, we see that who, what, where, sort of when, why, and how are 5 questions that are very important when you set out to start devising a study. So now let's take a look at the different kinds of study designs, or the different kinds of types of studies that we encounter in environmental epidemiology. So when we start talking about study design, the most basic study design is probably a case description. It's a very simple way of doing things. But a number of cases of very similar kind will constitute what is known as a case series. Case series is mainly descriptive, but some case series analysis can lead to very important insights and can generate hypotheses that then can be explored in other kinds of study designs. There are case series studies that can be used as case crossover studies to study association between an exposure variable and an outcome variable. We'll see example of both. Ecological study designs are study designs in which you study the exposure variable in an aggregate format from databases, and you link a health outcome also in aggregate format from databases, and then construct a linked database, and that linked data set then is analyzed. A case control study is one in which in which scientists sample participants of the study based on their outcome status. Cases are individuals who have the outcome of question. Controls are the individuals who do not have the outcome in question. And both for cases and controls, the likelihood of exposure is looked at. And the retrospective and prospective cohort studies are those kinds of studies where cohorts are assembled together, and then they are followed for occurrence of the disease. We start with the case series, and in case series we have a number of different cases that are studied together, along with but in case series basically we do the analysis only on cases that are recorded. Now, a couple of methods exist. One is the case, and here we are showing you, for example, the impact of 2 recent extreme heat episodes on the morbidity and mortality in Adelaide, South Australia. And you can see that in these case series studies, the dark line shows the number of deaths that were recorded on an extremely on a period when there was extreme heat. And at the same time, the broken lines show you the maximum and the minimum temperatures. And using this sort of an analysis, you can see people can get a sense that there is an association between heat and mortality. It was an important aspect. A very similar thing is with time series analysis, where you can see or can show that as over time, as certain conditions change, for example, here, the PM10 concentration of air, and then the total overall deaths in the elderly. This was a study conducted in Sao Paulo, Brazil, where the relationship between air pollution and mortality were studied. Once more, in time series analysis, the idea is to correlate, certain passages of time, certain variables. Say, for example, in this particular situation, pollutants in the air, and certain health phenomena. In this particular case, say for example, mortality. One of the things, one of the issues that one must keep in mind while interpreting studies on time series analysis is this, that they are open or subject to what is known as ecological fallacy, which means that based on the results of time series, you cannot extrapolate the findings to an individual. So that's something to keep in mind. Next up is a study design known as cross-sectional survey. A cross-sectional survey is exactly as it says. It is a snapshot in time. So you can see that there are these three windows through which a line runs. And what happens is this, that in a specific given time or time period, all persons are surveyed together. Now, one of the features of a cross-sectional survey is that it is here the exposure variable and the outcome variable, they're both surveyed together. And therefore, one of the defining, or say one of the strong criteria of establishment of causality is that the cause must precede the occurrence of the disease. So the exposure should precede the occurrence of the disease. That particular clause cannot be satisfied in a cross-sectional survey. However, cross-sectional surveys are simple and they're relatively inexpensive to conduct. Large cross-sectional surveys are routinely conducted by health departments and the Ministry of Health, for example, in New Zealand, to gain an insight into the prevalence of various conditions. Here is an example of a cross-sectional survey that was done by Stuart Welch and others in England, and they studied what is the relationship between built environment and depression. And you can see that they had conducted linear regression, and they had they are showing you the results here. You can see that the adjusted odds ratio for different kinds of features of a building with depression are like this. So, for example, the strongest one is that if a person were to live in a property that were built in 1970 or later, as opposed to buildings that were built before 1940, they were more likely to be to suffer from depression. It is quite an interesting finding, I think. And also, there are also a few things that are quite interesting. That is, if there are no shared recreational spaces versus recreational spaces, then there seems to be some sort of almost like a protective effect, which doesn't mean anything. And say disused buildings, of course, you can see that there are the high risk for depression. But these things, of course, change as the adjustments for various factors are done. So it's not a very interesting study, but it shows you that there are different ways in which people can analyze this sort of things. Case control study is a study in which we sample cases and controls. So cases are those individuals who have got the health outcome in question, and controls are the people who do not have the disease or health outcome that we want to study. And in each case, for both cases and controls, epidemiologists or scientists measure what is the likelihood of exposure for each group, that is the cases as well as the controls. And for each group, odds of exposure are estimated, and the effect measure for a case control study is known as an odds ratio. So let's take a close look at this. The effect measure is odds ratio. In this table, I show you the design of a case control study and tabulate the results. So altogether, there are A plus C number of cases, and there are B plus D number of controls. Out of A plus C number of cases, as you can see, A number of people were exposed to the exposure of interest, and therefore C number of people were not exposed to the exposure of interest. Among the controls who did not really have the disease in question, out of B plus D number of people, B had exposure and D did not have exposure. Therefore, the odds ratio based on this information is the cross product of E times D over B times C. As we will see and as we have seen before, using a case control study, you can also adjust for confounding by using a stratified analysis. Using stratified analysis, we can have more than one tables constructed, and in those, let's say we have got two tables constructed, and therefore we have got A1 and A2, B1 and B2, C1 and C2, and D1 and D2. You can construct those tables yourselves and can check. And the stratified odds ratio for two levels of exposure or for two levels of a confounding variable could be defined as E times, by summing up the numerator and denominator. And certainly, the stratification levels can be extended up to any number that we like. So this is about case control study. One of the limitations of case control study certainly is this, that there is a big risk of recall bias from people. And of course, the other issue is this, that because by nature case control studies are retrospective, therefore one cannot establish that in a case control study cause and effect associations. That is, cause should precede the exposure or the effect, or exposure should precede the outcome. That clause cannot be established in a case control study. Next, we look at retrospective cohort studies. Cohorts are individuals that are kind of like in nature. So they are groups of people, and cohorts are assembled ahead of time. And cohorts in a cohort study should not have the disease in question. And then these cohorts are followed. Either the cohorts are followed in retrospective time, that is in back time, or cohorts are followed in real time, that is in forward time. In this particular case, in a retrospective cohort study, cohorts are followed, assembled in past time, and cohorts are studied for their outcomes in historic time as well. So, for example, in a retrospective cohort study, the effect measure is a relative risk. This graph shows an example of a retrospective cohort study. Yin et al. In 1987 studied leukemia in Benzin workers in China, and they were studied, about between 1965 and 1979, I think. And what happened was this, that they had obtained data on their benzene exposure, and then compared them with the death that happened because of leukemia, and incident cases of leukemia in those workers. And you can see that that leukemia mortality rate in male workers at various ages, and you can see that there is increased risk as age increased. So this was a study in which the methods indicate that you look at the exposure in the past, outcome in the past, and study them from the records. Here's another one in which Hagberg and colleagues studied the incidence of tinnitus, impaired hearing, and musculoskeletal disorders among students enrolled in an academic music education. And this study was conducted at a university, and amongst students that studied music. And once again, you can see that there are some relative risks figures presented, and you can see that practicing hours more than 20 hours posed a risk, although it was not statistically significant because the confidence intervals straddled 0.94 to 2.70. But you can see that practicing hours more than 20 hours could be a risk factor for both impaired hearing and tinnitus. So this is an interesting study. Now we'd like to talk a little bit about prospective cohort study. In prospective cohort study, cohorts are assembled, again, disease-free cohorts are assembled in current time, and they're followed through future to determine the incidence or rate of the occurrence of diseases. And obviously at commencement, all members are free of the outcome or of the health outcome, and incidence rates are compared. Once again, the effect measure is relative risk. Prospective cohort studies are good study designs for studying a number of different health outcomes and common diseases out of a limited number of exposure variables. Here is an example of traffic-related air pollution and asthma onset in children. And in this particular case, Michael Jarrett and colleagues were able to measure air pollution exposure using personalized measurement instruments. And they followed these children till their development of asthma. Most prospective cohort studies and many prospective cohort studies are actually large-scale, broad-based, population-based cohort studies that can last for many years or many decades. For example, the NARSA's health study in the United Kingdom was a big study. And there are similar studies that are conducted all over the world, for that matter. Once more, take a look at these numbers and see what would you like to come to a conclusion. Well, you can see that with nitrogen dioxide concentrations, as that increases, there is a risk of increased diagnosis of asthma. And of course, the numbers vary depending on how we see these things. So you can see that there are issues with different seasonal variability, etc. So this was a very quick and simple roundup of the epidemiological study designs that are used in environmental health studies. In particular, case series, time series, cross-sectional surveys, and case control studies are quite widely used study designs. Prospective cohort studies are great study designs, but they have got some limitations. Retrospective cohort studies are quite extensively used in occupational health in particular. The key components of any good study design is to start with a good question. You can see that the same question can be answered by a number of different study designs that we've seen, and so you can start with a case series and follow up all the way to a prospective cohort study to answer the same question. And this was a quick and short introduction to study designs. Keep learning. Thank you.